So in this video we're going to look at Lambda expressions in Java. They were added to Java in Java 1.8. So this video is really designed for Java programmers that haven't yet got onto learning Lambda expressions. It's an introduction to Lambda expressions, but you're expected to understand Java interfaces and Java methods and this sort of thing. If we look at the definition of Lambda expressions in w3schools.com, it says a Lambda expression is a short block of code which takes in parameters and returns a value. Lambda expressions are similar to methods, but they do not need a name and they can be implemented right in the body of the method. I think the best way to learn anything in programming is by doing, so let's get straight into Lambda expressions and see what they do. So I'm going to create a hello world interface. To begin with, we're not going to be using Lambda expressions, we're just going to be using interface, and hopefully this will be familiar to you. So I'm going to write my code in the main method. And I'm going to create a sort of hello world interface. So it's going to say interface greeting. So I have a greeting interface with a single method greet, and I'm going to create a class of this type. Okay, so hopefully you're familiar with what this is. So I'm creating an interface greeting which has a single method, public void greet, and then I'm creating a class which is an implementation of this interface. So my greeting implements greeting, and that has the greet method, and the implementation of the greet method will system out print line hello world. Then in the main block of code we're saying create a new my greeting object, although we're treating it as the interface greeting, and then we're going to call the greet method greeting.greet. So that's a very long-winded way to say hello world. So that's a basic interface with one method. Very simple if you've used interfaces before, so nothing too difficult about that. Now we can take this to the next level. Now we can define the implementation of the interface inline as an anonymous in a class. Now the way we do anonymous classes is we just define them as we go. So we say greeting equals new greeting. So there we've defined the body of the class of type greeting inline as an anonymous in a class. So this has the same effect, we're just defining the greeting. When we instantiate it, we're defining the class. So this is the only version of this class, but we're just saying what we want our greeting class to do, and then we're calling greeting.greet. So the effect is the same, only now we have anonymous hello world. So now we're going to move on to Lambda expressions. We can use Lambda expressions to define functions in an interface which has just one method that we need to implement. Greeting is such an interface, so we can define greeting as a Lambda expression. So what we're going to do is say greeting Lambda greeting, and then we're going to define it in a very different way. First we have brackets, and these brackets, within these brackets we would put the parameters that we would pass to the greet method, but we don't need any parameters for the greet method, so the brackets are empty. Then we do an arrow, and then we can put our method directly in here. System out print line Lambda hello world. and then we can call lambda greeting.greet. So let's try this. So that's worked, and the reason that that's worked is because greeting has got just one method that we need to define, and so when we've defined our lambda expression, it knows which method we want this to be. So it's important that when we create an interface for using a lambda expression, we have just one method that's not defined in that interface. And when there's just one method not defined in an interface, it's called a functional interface, and we can actually mark the method as a functional interface. In this example greeting, if I made another method, public void greet2, then the lambda expression fails. It says the target type of this expression must be a functional interface. Now if I mark this as a functional interface, I can do that with an annotation, functional interface. Now we have an error on greeting, and it says invalid functional interface, lambda greeting is not a functional interface. And the reason it's not a functional interface is because it has two methods that need defining. So let's delete the second one, and it all works again. Now it's good to mark your interfaces that you're going to use for lambda expressions as functional interface, and make sure there's only one method that needs defining. Now we can pass these lambda expressions around as parameters. So to demonstrate this, I'm going to make another static method. I'm going to make this method called greet. And that's going to take in a greeting, and it's just going to call greeting.greet. So now instead of calling lambda greeting.greet there, I'm going to call the greet method and get that to do the call. So the effect is just still going to be the same, but now I can put this expression as a parameter to this method call, and the compiler will work out that we need to pass a greeting into this method call. Therefore it knows that we want that this lambda expression corresponds with the greeting interface, and when we run that we still have the same effect. Okay, so next I'm going to demonstrate a lambda function that has parameters coming in and out of the method. So I'm going to make a new interface. Instead of greeting, I'm going to make it string length. And this is just going to get the length of a string. So the public int get length of a string. So I'm going to find string length as a lambda. And now in the brackets we need to tell it the parameters, so string s. And if we just have one line, the return value can just be defined as the return from the method. So here the compiler is intelligent enough to know that when we call slength, we want to return that. So now we can call this method giving it a string with 5 characters. When we run that, it counts 5. Now the compiler also does type inference, so we don't actually have to specify the type string. We can take that out and it knows the parameter that needs to come into the method, the string, so we can just skip that string out there and just give it s. Obviously we need to give it s so it knows it corresponds with that s there. When we run that, the effect is the same. And actually, if we only have one parameter, we don't even need the brackets. So the lambdas are done in such a way that we can cut it down as much as possible. This can make it more confusing to begin with, but it does make it so that the lambda expressions are very efficient to define. So if we look again, it still works. Now if we need to make a multi-line lambda, we'll use square brackets just as if we were declaring a method. So now I'm going to change the getLength method. I'm going to change it to getLength after space. And what I'm going to do is in this method I'm going to pass it 1 2 space 3 4 5, and I'm going to change this method to give us the length of the string that appears after the first space in the string. So my lambda, what I want it to do, I'm going to give it a curly bracket after the arrow. I'm going to say s equals s substring s index of space plus 1, so that will turn s into just 3 4 5 because it's substring to the index of the space plus the space, and then I can do return s dot length, and now this should give us the length of 3 4 5, and when we run we get three characters in 3 4 5. So that's how we do lambdas when we have more than one line. Now I'm going to change my interface to be string property. I'm going to change the method to be getProperty of string. And I'm going to make a string property lambda. Called lambda length. That's going to give us s length. So that's going to give us the length of the string, which should be 6 characters. But now I can reuse this lambda string property, say lambda index of space, and I'm redefining the method of the lambda. Now we've used the same interface but a different definition of the getProperty method. So in the second lambda index of space, that's going to give us the index of the space in the string. So the first one is giving us 6, which is the length, and the second one is giving us 2, which is the index of the space. Now you can imagine that we can pass this into another method. And we can call that method directly with the lambda. And I'm also going to add the string itself as a parameter. So here I'm calling the same method on the string, my string, with the same string, but I'm saying that I want to run the string property method on this and system out print line the result of the get property of the string property method, and I'm telling the method what function I want to use for the get property method. So now we can see I'm calling the same method twice, but the first time I'm telling it we want to get the length of the string, the second time I'm telling it we want the index of the space. Now if we've got an existing interface that only has one abstract method, we can do a Lambda expression on that. So for example, if we want to do a thread, I'm going to make a thread the old way. So we'd say thread, my thread equals new thread. And that we would give it a new runnable. Runnable defines the single method run, and then to get that thread to execute we would say my thread dot start, my thread dot start. And we run this and we execute runnable thread in a new thread. Now because runnable has just one method, run, we can do this as a Lambda expression. So let's do the same thing again, but doing it as a Lambda expression. Thread my Lambda thread equals new thread. And what would we do to thread? What did we do to thread here? We gave it the runnable. We defined an anonymous inner class runnable, and we defined the method there. So with Lambda, all we need to do is define the method here. Now run takes no parameters in, and we can just say what we want the method to do. System out print line Lambda thread. And then my Lambda thread start. And you can see that if we've got a thread with just a simple method definition, it's much quicker just to define it as 2 lines there. And both of those methods work, but the Lambda version is much more easy to just pass the method body into the thread and have it create the interface. Have the compiler create the interface internally. Okay, so now I'm going to demonstrate how Lambda expressions can be used with a bit of an exercise. So I'm going to create a car object. It's a class car. And this car object, I'm going to give it a string make, a string model, and an int year, so the year the car was made. I'm going to generate a constructor from the fields. And I'm going to generate getters for each of the make, model and year. Now I'm going to make a list of cars. I'm just going to define car in a separate class to tidy up the code and also save having to instantiate an object so we can do it in the main method. So there we have a little cars database, a list of cars. We've got a Ford Mondeo from 2005, Vauxhall Corsa from 2010, Ford Mustang from 1980 and a Mini Cooper from 1985. So here are the things that we would like to do to our cars. Okay, so I want to sort our cars list by the age of the car. Step 2, I want to print all our cars in our cars list, and step 3, I want to print cars that the model name begins with a C. So first we're going to sort our cars by age. The way we do this, I'm going to do this without using Lambda. I'm going to do all of these things without using Lambda expressions. So collections.sort cars, and then I'm going to make a new comparator which works on car. And that comparator is going to return the o1.getYear compare to o2.getYear, so we're telling it to compare the years. I'm just going to change the year to the integer object so that we can call compare to on it, because it's not a primitive type. Then print all cars, I'm going to make a method and in that method I'm just going to loop over all the cars and system out print line the car. Another thing I'm going to do to a car object is give it a toString method. So that when we print it we can call that toString and we've got a nice formatted description of the car. So step 2, we want to print all of the cars. And step 3, we're going to print all cars beginning with C. I'll make this a bit more generic in a moment. But for this we're going to loop through the cars, but we're going to say if car.get model starts with C, system out print car. So step 3, print all cars beginning with C. So that's all straightforward Java. So let's see whether it works. So all cars, we've got the Ford Mustang, they've been sorted in date order by step 1 of our method. Then we output all the cars, and then we output just the Mini Cooper and the Vauxhall Corsa, just the ones beginning with C. Now, of course, this all cars beginning with C is a bit of a strange method, so instead of doing it this way I'm going to create a filter interface. So here's how that's going to work. I'm going to say interface filter, and in that filter I'm going to just have one method, public boolean matches. And I'm just going to have a print car method, and that I'm going to take in a filter, and instead of comparing whether it begins with a C here, I'm going to say if filter.matches car, and then we have more of a generic method which is going to be able to print cars filtered by any filter method we give it. So now instead of doing that, I'm going to say new filter and we can put the method if the body starts with C into the filter, and that's going to have the same effect as before, but you can imagine that that filter method could be used to do anything in here. So we could now use this print cars method to filter by age or filter by model or make or whatever we want to do. So that's a much more generic way of doing the conditional printing of the cars. Actually, we can take this a stage further now, and the print all method, we can get rid of that. And we can call print cars with a filter, and the filter can just return true. So that print cars with a filter which always matches is the equivalent of printing all. So still everything works the same. Okay, so now we're going to modify this program which sorts the cars and prints them out according to filter. I'm going to modify it to use Lambda expressions. So firstly, on this sort, we're doing collections sort with a comparator. Now a comparator is an interface that has just one abstract method. That abstract method is compare. So here we can do a Lambda expression. So I can say collections.sort cars, and then I can do a Lambda expression to define the method compare here. So what I can do is just cut all of this out, car 01 and 02, then the arrow, and then cut this out. And that's it done with the Lambda expression. Because of type inference, we can even get rid of the cars. And there we have our sort method done in one line of code with a Lambda expression defining the comparator method. Next, our print all method is taking a filter, which is another interface here with just one method, which takes a car and returns a boolean whether it matches or not. So here we can define that as a Lambda expression. So that takes a car. Because there's only one, we don't need to do brackets. We could do car C. There's only one parameter, so for type inference we don't need to tell it it's a car, and because there's only one parameter we don't need the brackets, so we can just say P arrow and true, the method body. And all cars beginning with C, again here we can just do C, the arrow and the method body. And you can see that we've taken those inline anonymous interface declarations and just cut them straight down, and each method call is one line of code. When we run, we see the cars are still sorted in order. All cars method is matching with all cars, and all cars beginning with C is matching the Mini Cooper and the Vauxhall Corsa. So the effect is just the same, but we've cut our method down quite a bit. Now I'm just going to take this to the next level, and this print cars method, what we actually do to the cars, I'm going to define that as a lambda as well. So I'm going to make a new interface, output, public void, output car. And here I'm going to have the output method so we're not necessarily going to system out print line, we're just going to call the method output for the car, but in the methods I'm just going to define it to be system out print line. So now we're not only defining the filter, we're also defining what we do if the filter matches. So I suppose this should be output cars now, but we'll keep it as print cars. So let's see this working. So the result is still just the same, but now the method is even more generic. We're telling it what we want to do to the cars that match the filter. So we've got two functional interfaces here. One is filter, which takes a look at our object and returns a boolean if it matches, and one is output car, which takes our object and does something to it. From the interface point of view, that is what we know. You can imagine that these particular things, we're not the first person ever to define functional interfaces like this. So Java provides some functional interfaces for them. So let's take a look at those. Okay, so here's a list of the package java.util.function, and we can see we've got a whole list of functional interfaces that are provided by Java. So if we look at some of these, we can see that they're quite generic. So for example, if we look at the first one, we've got a by consumer, which takes two generic types, and it represents an operation that accepts two input arguments and returns no result. So that's you can imagine that's quite a generic thing to do, take two arguments and return nothing. And now let's have a look at two particular ones that I want to show you, and that is predicate. Predicate represents a predicate which is a boolean valued function, so it returns a boolean and it takes in one argument. The other one I'd like you to look at is consumer. This represents an operation that accepts a single input argument and returns no result. So now if we look back at our program, we have here a filter which takes in one argument and returns a boolean, so that is really a predicate. And output takes in one argument and returns no result, so that really is a consumer. So we can use the functional interfaces defined in the Java package rather than rewrite these interfaces. So let's just get rid of these interfaces now. Now all we need to do is change filter to be predicate. Acting on car, and change output to be a consumer of car, and then we need to just change the method names. So predicate has test as its method, and consumer has accept as its method. So there we've made our program even easier because we're using the ready-made functional interfaces in Java. When we run our program, it still works just the same as it did before. Okay, so I'm going to cut this code down quite a bit, and I'm going to create a list of strings. I'm going to add a method perform, which is going to perform something to each element in our list of strings. And for that method, I'm going to provide it with a consumer, so we're not going to redefine the consumer interface, just going to pass it the consumer. And this method is going to, for each string in our list, it's going to call the consumer except s. And then here I'm going to call perform with my list, and with the Lambda expression system out print line s. So the method for the consumer is going to be system out print line s, and we're just going to loop through the list and system out print line each string in the list 1, 2, 3. So in the Java doc it says you can use Lambda expressions to create anonymous methods. Sometimes, however, a Lambda expression does nothing but call an existing method. In those cases, it's often clearer to refer to the existing method by name. And we can use method references for this. So the consumer method is going to call a single method, system out print line, and that's going to take a single parameter as an argument, and system out print line has a single parameter as an argument. So we can do a method reference here. Now how we do method references is we put the object that contains the method, and then we put 2 colons and then the method name itself. We don't need to provide the parameters, as long as when the code is run the correct number of parameters are sent into the method, it will work. So here we want to do system out print line, so we can just do it simply like this. So we're just passing the method. System out is the object because out is the object in the system class, and print line is the method. So system out colon colon print line, and the code will work just the same. Now we can simplify this program in another way. That is that in list we now have a new method for each, which takes a consumer as a parameter. So since Java 1.8, for each has been added to iterable lists. So we can say my list for each, and then I'm going to do a method reference, system out print line, and that's a new way to do a for loop over a list and system out print line each element in the list. 1, 2, 3, the result is just the same. Okay, there are some other methods that have been added for us since Java 1.8, and another example is that we can use streams on lists. So if we do stream, we can do a series of things to our list. So stream gives us a few other methods. So for example, we can filter by a predicate. So here I'm going to filter and say if our string starts with the letter T, and then I'm going to add another method onto that. For each one that does start with the letter T, we're going to system out print line. So now you can see from the stream we're filtering by the predicate, and the predicate is going to return true if S starts with T. And then for each one which matches, we're going to run the consumer method system out print line for each. So let's see that prints 2 and 3. So there's an example of how we can use a stream. Now what a stream does is it has intermediate methods, for example filter. So we can see here that filter is an intermediate operation, and if the filter returns true, it will go on and do the next operation. If not, it will not add the object to the new stream that it returns, so it won't continue. And then for each is a method in stream, and that's a terminal operation, so this is the last thing we want to do to a stream. So you can imagine you can have intermediate operations on a stream, and you can do many filters with predicates along the way, and then finally you have a terminal operation that you'll do to each thing which hasn't been filtered out of that stream. So that's a pretty concise way to filter things in a list and then to do something to the remaining things at the end. Okay, so that's it for Lambda expressions. This has been an introduction to Lambda expressions. Obviously practice makes perfect, as it does with most things in programming. So I hope this has been helpful for you. If it's been useful, then give the video a like, and if you'd like to see more programming tutorials and programming related videos in Java, then subscribe to my channel. So thanks for watching.